Hi. Well, I thought we'd go ahead and look at 11.3. We're almost finished. This is one of our last sections, not the last, but one of the last ones. And what it's going to talk about is the quadratic formula, but it's only going to talk about a certain part of the quadratic formula. And that happens to be the part that's under the radical. And they've assigned it a name underneath here. They call this section underneath the radical, not including the radical itself, just the b squared minus 4ac, it's called the discriminant. And the discriminant will tell us the types of solutions we have, whether or not they're rational, are they irrational, are they imaginary? Those are some of the things that the discriminant will tell us by just knowing its value. So we're going to go through a few examples. And first off, we're going to start with if the discriminant, which would be b squared minus 4ac, what happens if that discriminant, okay, is equal to 0? All right, what does that tell you about the solutions? Well, they tell us here that in this case, there would only be one repeated solution. So let's go ahead and go through an example. So in other words, if the discriminant happens to be a squared minus 4ac, happens to be 0, you will have one solution. Well, let's talk about an example and what that means exactly. And remember, this discriminant is part of the quadratic equation. So looking at this example here, using the discriminant, I'm going to go ahead and fill in the discriminant and we'll see what we've got. We take the b, so we know that this is the a is 1, the b is 10, and the c is 25. So we take 10 squared minus 4 times a times c. So we get 100 minus 100, which is equal to 0. And we're told that if the discriminant is equal to 0, we will have one solution. Well, let's go ahead and apply it to this so you can see why we only have one solution when the discriminant is 0. So we're going to take our minus b, okay, we're going to take all of our information and put it into here. We have minus b, and in our case it's 10, so we take the opposite, which is a negative. And we found the b squared minus 4ac, we found that to be 0, all over 2 times 1. Because that's 0, that's gone. So we end up with a negative 10 over 2. We end up with just one solution because our plus or minus that would have given us 2 solutions is gone. Because a negative 10 plus 0 is a negative 10, and a negative 10 minus 0 is also a negative 10. So you end up with one solution of a negative 5. That also tells us that our equation, because we have this double root, our equation was a perfect square trinomial. So in this right here could have been factored as a perfect square trinomial whenever that discriminant is 0. It means that when we factored this, they matched exactly. So 5 and 5 multiplied is 25, 5x and 5x is 10x. So our solution, if that's 0 or if that's 0, since they match, it doesn't matter which one you use, is a negative 5. So if you do get a 0, it means that inside the radical you have a 0, so this part disappears, and you end up with one solution. And this solution will be one real solution, one real rational solution. And it also meant that your equation was a perfect square trinomial that could have been factored using matching factors here. All right. Okay, that's if the discriminant, b squared minus 4ac, is 0. We end up with one solution. one solution. All right. But what happens if it's not 0? Let's look at number 2. Now, if you take your discriminant, b squared minus 4ac, and it's a positive number, doesn't matter what number, if it's a positive number, it means you have 2 real solutions. Now, real numbers can be rational or irrational. And so let's break it down even further. Once we know it's positive, we can determine if it's rational by looking at the number that we got, whatever the discriminant number is. We can determine if they're going to be rational, or we can determine, depending upon this positive number, if they're going to be irrational conjugates. So let's look at an example here of number 2 and kind of explain that a little bit better. Okay, so again, if our discriminant is positive, we're going to have 2 real solutions. But let's determine if those 2 real solutions are rational or irrational. Let's start with irrational. First off, let's find the discriminant and make sure it's positive. So here, let me see. Yeah, okay. Number 2, they don't give us an example exactly. So we're going to go ahead and we're going to find b squared minus 4ac. That's our discriminant. We're going to see what that value is. Now, here a is 1. Okay, so there's our a is 1, b is 6, and c is a negative 7. I'll just put those at the top there. So we're going to take and we're going to square our b. 4 times a times c is a negative 7. So we end up with 36 plus 2 negatives is a positive 28. When we add those together, we get 64. Now, if this number is called a perfect square means that when I do take the square root, I only get a whole number. Not necessarily just a whole number, but I get a rational number with no radical. So here, this would be 8. Okay. So if this is a perfect square, like 64, 49, 36, 100, 121, which means I can break it down into, when I take the square root, when I'm using the formula over here, I get 7, 6, 10, 11. There's no radical. Okay, when I do finally put my discriminant in, there's no radical, which means that it's a rational number. When there's no radical, it's a rational number. Well, let's go ahead and figure this. Let's go ahead and we know that our discriminant was positive, so we knew that we have 2 real solutions. Because it's a perfect square, I know that it's the square root would be 8, so it's going to be a rational real solution. Let's go ahead and find that. We'll take opposite of b, which is a negative 6. We know that b squared minus 4ac is 64, all over 2, and our a is 1. So we end up with a minus 6 plus or minus 8. I no longer have a radical. That's why it's rational. And it's real because there's not a negative inside here. So it's not imaginary. So again, here you could divide everything by 2 if you want to. And that would be over 1. Okay. So we take a minus 3 plus 4. So we have, there's one of our solutions. Negative 3 plus 4 is 1. Negative 3 minus 4 is a negative 7. So I have 2 real rational solutions. Rational can be a fraction too, just as long as there's no radical. You're good. Okay. So again, our discriminant was positive and it was a perfect square. So I mean, we could take the square root of that and get 8. And 49 would have been, if we would have gotten 49 as our discriminant, 36. These are examples of when you will get a rational real, okay? But what do we mean? What happens if it's positive? And how do we know if it's irrational or not? Well, let's look at our discriminant. We have b squared, and let's fill that in. See what this value is. Here, this is A is 1, B is also 1, and C is a -3. So let's fill it in. 1 squared is, well, I'll just go ahead and put it down. 4 times 1 times a -3. 1 plus 2 negatives is a positive, 12. So I get 13. Now, this is not your perfect square, okay, because something times itself does not give me 13. So this is, because this is not a perfect square like we had our examples up here, if we would have gotten these as your discriminant, then we would have known we had rational solutions, 2 rationals. But it's a 13, which cannot be reduced, so it's going to be irrational. And they're going to be conjugates of each other. Whenever they're irrational, they're conjugates. Let's go ahead and go through why it's irrational conjugates by using this in our quadratic formula. So we'll take the opposite of b, so we get a -1. That's why it's conjugate, plus or minus. That's going to give us our conjugate here. Square root of 13. I do know that b squared minus 4ac is 13. All over 2 times 1 is 2. So there's your solution. And I've got conjugates here. I've got a -1 plus the square root of 13 over 2, and a -1 minus the square root of 13 over 2. Again, conjugates mean that you just change the sign. And we have a -1 minus. Okay, you just change the sign there, which makes them conjugates. So because this could not be simplified, it made them irrational. And we'll always have, when you have irrational, you'll always have conjugates, always. Okay, whereas if you have rational, they're not conjugates. They're not conjugates. Okay, let's look at our last one, and that is, what happens if our discriminant is a negative number? What happens then? And we know that in this case, there are 2 different imaginary solutions or complex conjugates. So we'll end up with conjugates again. So whenever you have complex, when you've got that I, they'll always come in conjugates. They always come in those pairs. Your solutions do. So let's look at an example quickly to explain that, and then we'll go through 3 more examples and be done with this idea. If b squared minus 4ac is negative, okay, we have 2 complex conjugates. Why? Let's go through an example. We have b squared. Here's our discriminant. A is 1, b is 1, c is the number 5. So we're going to take b and square it. Minus 4, a is 1 in this case, and b is 5. So 1 squared is 1, minus 20. So we end up with a -19. Why is this imaginary? Why do we have a complex number? Because when we put that back in, we're going to have a negative under the radical, which makes it imaginary. So let's finish it knowing we will have 2 complex conjugates because our discriminant was negative. Here, let's find our 2 complex conjugates. A minus b, so we take opposite of b, which is a -1, because the b is positive, so the opposite of b. We found out what the b squared minus 4ac is. it's a negative 19 all over 2 times 1, which is 2. So simplifying this as far as we can, we have a negative 1 plus or minus. That means we have a conjugate. This is going to be I square roots of 19. The only thing that can come out of that radical is an I. The square root of a negative 1 is I. So those are your two solutions, okay? Well, let's go through a few more examples as to, and I'm hoping that when you think about putting this discriminant back in, it helps you realize why you have imaginary, why you have complex. When you put the discriminant back in under a radical, why the radical stays, which makes it irrational conjugate, a positive 13. Why, when you put this back in underneath the radical, you can simplify it to a number with the radical is gone, which makes it a rational, two real rationals. Or our first one, if you get a 0 for a discriminant, why do you only have one solution? Because when you put that discriminant back in, this part is gone and you're left with one solution. It also means that you have a perfect square trinomial, which is very easy to factor. Okay? All right. Let's go through 3 more examples of this idea, and then we'll talk about a whole new concept here. Well, it's a review. It's a review of something we've done earlier. Okay, let's look at our example A here. Let's go through this one. We want to find the discriminant. And when we do that, we will, I was going to put the whole quadratic formula, but. So we're going to determine the types of solutions, and then on the next page, we'll actually find them. So we've got b squared minus 4 times a times c. I don't know why I put parentheses, but that's okay. Okay, so we take b squared, negative 12 squared. Remember, that'll always be positive when it comes out. Minus 4, a is 9, the c is 4. So we end up with 144 minus 144. 4 times 9 is 36, times 4 is 144. So what happens then is our discriminant is 0. So we do know we're only going to have one solution. Now you can find this solution. When we have one solution, we know that this is a perfect square trinomial. So to find that one solution, we could either use the quadratic formula, we could finish it using our discriminant, or we could factor it, okay, using a perfect squares. So, but we'll do that on the next page. So we do know we have one solution. Now let's go ahead and look at this right here. Now again, I'm sorry, going back, they said, you can list, which I kind of went through. You could factor this. You could complete the square. I would probably either factor, or since you've already have the quadratic formula started, you could finish it with the quadratic formula. Okay, let's look at this one here. B squared minus 4ac. Let's see what our solutions look like. A is 1, B is 5, and C is 8. We have 5 squared times 1, C is 8. So 25 minus 32. So in this case, we end up with a negative number. So here we end up with a negative 7. That tells us that we have two complex conjugates. We have two complex numbers and they're conjugates of each other. Now, when you do have complex, you're going to need to use a quadratic formula, because factoring, you could complete the square. You could bring the 8 over and then divide that by 2 and square it. But when you divide that by 2, to see what you're going to add to both sides, when you're doing completing the square, you end up with a fraction. So in this case, I would just use the quadratic formula to find your imaginary answers here, your complex answers. Okay, all right. So we have, I guess we could put complex conjugates. And which means we'll have an imaginary number in there because we'll have a negative in that radical. So this really shouldn't be too bad. Let's try another one, and then we'll go back and find the exact solutions to what we just did. Okay, we're going to take b squared minus 4ac and see what do the solutions look like here, depending upon the value of this. So we're going to take 7 squared minus 4 times 2 times a negative 3. Now, when we do this, we've got 49 plus we have 8 times 3 gives us 24. Okay. So then when we take the, when we add those together, we get 73. So that tells it it's not a perfect square. It's not 64, it's not 49, it's not 36. So we know that our radical will be left. So we have this positive, so we have 2 real, because it is positive, and they're going to be irrational, because you can't simplify this totally if you take the square root. So they're irrational. So they're 2 real and irrational. Okay, it's positive, which makes them real. This cannot be simplified in the radical, so it makes them irrational. Okay, now let's take those 3 and let's go ahead and finish them. Now this first one, we know, if I can move this here. This one right here, let me cover up the rest of this. Okay, we know that because we found the discriminant to be 0, we have 1 solution. And because of that, I know I could factor this to find that solution, or I could finish using the quadratic formula since I pretty much have it already started. But let's go ahead. I'm going to factor it as a perfect square trinomial. Whenever that's 0, you know you can do that. So these have to match, the 2 and the 2, and they're both negative. Okay. Now you get negative 6x and negative 6x is a negative 12x, which is kind of a nice review of factoring. So if this is 0, we only have to do one of them since they're the same. You add 2 and divide by 3. 2/3 is your solution using factoring. If you did want to finish, rather than doing this, knowing that it's a perfect square trinomial because the discriminant is 0, or you could finish using the quadratic formula and fill that in. I'm going to kind of move this to the side now. I'm going to say, okay, we have a minus b. We have a minus b, the opposite of the b. B is negative 12, so we have the opposite of b, a positive 12, plus or minus. We found the discriminant, which is inside, to be 0 over 2 times a, which is 9. So 12 over 18, because that's gone, which can reduce. 6 goes into both of them, 2 and 3. So either way, you'll get the same answer, you know, and it doesn't hurt to practice the factoring. Okay, but you can, because you've already got part of your quadratic formula already completed, you could just go ahead and finish using that number that you got from the inside, the discriminant. But again, there's only one solution, 2/3. Okay, one real solution here. All right, let's finish our B. Now here, B, we found, I keep moving my coffee back here. Let me try to cover up A so it doesn't look quite so confusing here. There. Well, let me move it up if I can. There. Takes me more time to arrange it than it does to do the problem. All right, now on B, I know that my discriminant came out to be a negative. Don't even try to factor. All right, if that discriminant is negative, you're not going to be able to factor it with those imaginary numbers and come up with the right factoring. So when you do have a negative, just go straight to the quadratic formula. You could, like I say, you could complete the square. I personally think that sometimes the quadratic formula is a little bit easier or faster. So let's go ahead and we're going to go ahead and complete the square, or not complete the square. We'll use the quadratic formula, minus b plus or minus the square root of b squared minus. And okay, so here we have the opposite of b. Now b is 5, so we'll have a negative 5. I know that this right here, we've already done it, is a negative 7 over 2 times 1. So we have a negative 5 plus or minus makes it our conjugate. We'll always have a conjugate when we have these imaginaries. I'm going to take the negative out as an I. Everything else has to stay in. 7 can't be broken down. If there were 2 of something, I would take it out. This cannot be reduced because there's not a number that goes into negative 5, 2, and 1 other than 1. So there's your 2 solutions. And they are imaginary. We figured that out using, we figured they would be imaginary. I pointed to something you couldn't see. We knew that they were going to be complex conjugates because of the fact that it was a negative. Our discriminant was a negative. All right. So I just used the quadratic formula to find those solutions. Okay, last one. And we can look up here. Oops, maybe. I know that my discriminant was 73. So I do know it's going to be irrational, so I'm not going to try to factor. Okay. Now, if that had been a 64 or 36 and I would have been able to, like get a 6, then you could have factored them. But because it's irrational, we're not going to factor. We'll use the quadratic formula. So I don't really want to complete the square because that leading coefficient is not a 1, and you have to divide everything by 2. You've got a lot of fractions to work with. So we'll just use the quadratic formula, knowing that we're going to get some irrationals, but no imaginaries, since it's positive 73. Okay, we have a minus, the opposite of b, so we have a minus 7, because remember, there's our a, b, c. So then we will take the square, b squared, the square root of, never mind, we've already done this part. No sense in doing it again. We did that up above. We found inside to be 73. So we'll just put that in there. All over 2 times a, which is 2. Minus 7 plus or minus the square root of 73 all over 4. Now, you can ask yourself if 73 can be reduced. Can you bring in 2 of anything out? And that 73 cannot be broken down. So we have to leave it like that. And so we have the irrational and their conjugates, because we have a plus, negative 7 plus the square root of 73 over 4, and a negative 7 minus the square root of 73 over 4. Conjugates just change that middle sign. So there's your solutions. Okay, all righty, perfect. Well, that's enough of the quadratic formula and what the discriminant and how it can help you decide what type of solutions you have. So the next thing we're going to look at probably may seem totally different, but it is a review. And what it deals with is, now we're going to be given the solutions. We're going to be given these solutions, and we're going to be asked to, we're going to be asked to go backwards. So given these, You're going to go to this and multiply it and come to this right here. I got to turn my phone off. It keeps dinging. There we go. So how do you do that? Given this, how do you go to this? And once you get to here, how do you go to here? Well, when you set this up, if you're given a -4, notice that this was a +4. So you change the sign here, because when I use my product property, I set this equal to 0 and solve it. So when I subtract 4 from both sides, I get this. So here I change the sign and I had 4. Here, if I were to solve this, I get a +1. So you change the sign so that when you solve it, you come up with a +1. So given these, you just go to here, change the sign, put those numbers in there, change the sign. Now, how do you go from here to here? Well, in this case, you would use the FOIL method and multiply it out. So if I had, let's say, -7 and a +8 as my solutions, let's at least get to this step. Well, if it's a -7, that means I had to have a +7 in my factoring. Because if I set this equal to 0, I subtract 7 from both sides, and I get that as a solution. If I have a +8, it means I had that as a factor, equal 0. And then you would just use the FOIL method to go one step further. All righty? So let's go ahead and let's look at our first problem there. This one here. Let's find an equation. Now you're saying an equation. It may not be the equation. We have to have some information to come up with an exact specific equation. But given just the two solutions of 2 and 3, what would this equation look like? And we have a 2, which means I had x -2, because if I solved it, I would go back to that as a solution. 3 means I had x -3. There'll always be the opposite signs there, because when I solve this, I come back to that solution. Okay, equals 0. We'll set it equal to 0. Now, let's go ahead and finish using our FOIL method. So we'll take our FOIL, just get a good review. We have a final coming up, doesn't hurt. The first times the first. X times x is x squared. Then the outside and the inside. -3x. The inside is a -2x, gives us a -5x when you combine those two together. The L is the last times the last, which is +6. And there you're done. That's it. So x squared minus 5x plus 6. What you could do, is this correct? Is this the right answer? You could do this on a test. Put 2 into your x's, and you should get a 0. Put 3 into both x's. 9 minus 15 plus 6 is 0. So these are the solutions to this. So you can check it, which is a really good idea on tests. You have time. I've given you enough time. All right, let's look at another one. But in order to look at another one, we might need a little bit more of a skill in helping you to solve that. Okay, we've done this one. All right. Let's look at what happens if I give you fractions. Now, you could, and this is actually what the book does, is they would take this and go x plus 1/2, and they would make this x minus 2/3, and use the FOIL method using these fractions. But that's not as easy. I think it's a lot easier to go from here back to here. How do you do that? How do I know that this can be written as this? Well, if I solve this, 2x plus 1 equals 0, I should get a negative 1/2. I subtract 1, and then you divide by 2, so it works. 2/3, how do I know that is that this 2/3 is the solution to this? If I set this equal to 0, let's see, we add 2, then we divide by 3, so it does work. So how do you go from here to here? Well, first off, it's opposite, so we know we have a plus. And over here, the 1 goes in the numerator, okay? So the 1 goes here and the 2 goes here. That's what you're dividing by, is the number next to the x. Here we divided by 3, and we have, first off, it's positive, so we make it minus. Then we have 2 because we added the 2, so it's in the numerator. And the 3 next to the x is in the denominator because that's what we divide by. This is a lot easier to use the FOIL method than dealing with all of these fractions here. Well, let's go ahead and let's practice. Let's do a few samples of going from here back up to here. How do you go from here to here? It's not that difficult, and it sure simplifies it. Fractions are not fun to work with. So I came up with some examples. And I gave you the solutions. And in this case, there were 3 solutions. We're not going to multiply it together right now. What I want you to practice, though, is going from a fractional solution to something that's easier to work with when you do multiply it out. Okay, let's talk about this one. Okay, we've got, it's going to be a plus. The 5 will be in the numerator, and the 3 is what you divide by when you set this equal to 0. When you set this equal to 0, you should get this. Subtract 5, divide by 3. Let's look at our 7/9. And you guys can always pause it and try it and then see if you get the right answer. But here we have a negative. It will be a subtraction. It's always going to be the opposite. We have a 7 in the numerator, and we're going to be dividing by 9x. So you would add 7 and then divide by 9. And this way we're getting rid of the fractions. Let's look at this one. It's going to be a plus because it's always opposite. And I know that we subtract 1 and then we divide by 8 when setting that equal to 0. We're not going to do this, but I'll talk you through how do you find the final solution. It's going to be a cubic equation. We had the 3 solutions, so we're going to have an x cubed in here. What I would do is, now you can multiply these 2 together first, and then you take that answer times this one, okay? So you would multiply this using the FOIL method. They're kind of large numbers, so I really don't want to do that. We'll practice it here in a minute. And then you take that answer times this one right here, okay? All right. Well, let's go ahead and look at a sample of this on your homework sheet. And then we'll almost be done here. Okay. This one, let's come up with, we only have 2 solutions. It's a quadratic, that's nice. So here we've got x minus 3. It's the opposite. And then this one is going to be a plus. We have the 2, and the 5 is what you divide by when you set this equal to 0. You can set it equal to 0. You'd subtract 2 and then divide by 5, and you come up with that solution. And so we're going to go ahead and, seems a little rough, but that's okay. Use the FOIL method. Finish it. The first times the first is 5x squared. And then we're going to take 2x and a minus 15x. This is our OI. And we'll come up with a minus 13x. The last times the last is minus 6. There's your equation. So now to check your equation, put 3 in for both of the x's, and you should get 0. And then put a negative 2/5. Listen, when you substitute in the negative 2/5, you must use parentheses around the negative 2/5. So when you put that in, okay, the squared is outside the parentheses, obviously, minus 13, and you should get 0 on your calculator. You put those in right. Perfect. Okay, let's try one. You get an equation. You can have imaginary solutions, but notice, oh, it seems like there's a delay, but that's okay. Notice that there's that they're conjugates of each other. It's a 2i and a negative 2i. So if for some reason a teacher were to say, okay, 4i is a solution, it's not the only solution. You have to, and you would have to add the negative 4i. You will never have one without the other. Okay, so kind of keep that in mind. That they'll always come as conjugate pairs. So if you're only given one, go ahead and add the other one. It's there. But I'll just go ahead and give you both of them. So here I have x minus 2i. I have the opposite of that one. X plus 2i. Okay, so I changed the signs on those guys. Now I'm going to use equals 0. I'm going to go ahead and I'm going to multiply this out, which kind of helps us working with our i's from our previous section 10(8). So we take the first times the first. Then we have a positive 2i and 2ix. When I take and multiply the 2i times the x, a 2ix, and a negative 2ix. And they cancel out. There's 0. There's no I there, so they're gone. So there's no middle term. So then I'll take the last times the last. So a negative 2i times a positive 2i is a negative 4i squared. Okay. Well, that can be simplified because we know that I squared is a negative 1. So a negative 4 times a negative 1, I might put that negative 1 down below. It's kind of interfering with this up here. That's a negative 1. So you get x squared plus 4. Negative times a negative is a positive. And that equation has those roots. How do you substitute that in to check? Well, you put the 2i in for the x. We'll just check this one. We get 4i squared because you square the 2 and you square the I. 4 times a negative 1 is a negative 4. And so you, oh, sorry about that. You do end up with 0, so it does work. Now, if you put a negative 2i in, whenever it's even, if you square and even, it becomes a positive 4i squared. So you end up with the same thing. Okay, all right, no problem. We're finishing this thing up here. I'm not sure what's going on with our dogs. I'm sorry about that. I don't know. Okay. Let's go ahead and let's write this out. So we'll have the opposite, x minus 5 square roots of 7. X, the opposite of that is plus 5 square roots of 7. Okay. And we use our FOIL method, equals 0. So we'll go ahead and we'll use our FOIL method in order to multiply that out. When you've got these conjugates, Notice I've got a minus and a plus. These are conjugates of each other. The middle term will always drop out. So, which is kind of a nice. Okay, let's take x times x. The first times the first, we get x squared. Then here we have a positive 5 square roots of 7x and a negative 5 square roots of 7x. They drop out. So we do know that when you multiply conjugates, your middle term will always drop out, just like on the last one. It doesn't hurt to check. And now we're going to take the last times the last. A negative times a positive is a negative. 5 times 5 is 25. You multiply what's outside, multiply what's inside when you multiply them together. Okay. Now let's simplify that last term. X squared minus 25, the square root of 49 is 7. And whatever comes out, you multiply by what's in front. Okay, so x squared minus, that should be 175. Okay, alrighty. So you come up with x squared minus 175. So, we'll check. You could substitute those in right here and square it. And when you square this, you get 25 square roots of 49. So when you square that and subtract 175, you get 25, you square that, and then you square that. So 25 times 7 is 175 minus 175 is 0. Okay. So it does work, so it doesn't hurt to check. All righty, let's try another one. Now, these last ones, I had 2 solutions. Because I had 2 solutions, I knew I was going to have a quadratic, a squared as being my highest power. But what happens if I have 3 solutions? Ooh, and what if one of them is 0? What does that mean? Well, let's go ahead and go through this. This x minus 4, that meant I have x plus 4. Change the sign. X equals 0 means I just had an x in there, just x. Usually you put the x in front, which I will here in a minute. I'm just kind of going in order as we see them. And that would be x minus 1. So probably the only new concept is if you have a 0 and then you meant you had an x. Okay, just an x. I would rewrite this. And this is the way we usually see it when we factor. I'm going to put that x out in front, equals 0. So if you do have a 0, just put an x. How do you multiply this? What I would do, because order doesn't matter in multiplication. So what I would do is I would multiply these 2 together first, all right? It's the commutative property of multiplication. Order doesn't matter. So I would multiply these together, and then I'll take that answer times x. It doesn't matter. To me, this is the easiest way, though. You could use the distributive property and take x times everything, take that answer times this. But it is easier to go ahead and multiply these 2 together first using the FOIL method and ignore the x. FOIL. X, the first times the first is x squared. Then I have a minus 1x and a 4x gives me 3x. Last times the last is minus 4. And then we take everything times the x after that. So this gives you x cubed plus 3x squared, adding exponents, minus 4x when you use the distributive property. And there's my solution. You can check it. Put in a negative 4, and you use parentheses, especially when you have that even power. And put negative 4 in for the x's, you'll get 0. Put 0 in for the x's, you get 0. put 1 in for all the x's, and you should get a 0. So these are the solutions to this equation. Okay, let's practice this idea one more time. And we'll be done. We'll be done with this one. I have to check the time real quick. Yeah, we're doing great. So here on this, I have I have a minus 2, which means I will have x plus 2. Take the opposite. Then on this one, it's a positive 2. I'll have x minus 2. Take the opposite. And then I'll have 3, x minus 3. So with this solution to this one, if I were to set it equal to 0, gives me this. Set this equal to 0, I get this. Set this equal to 0, I get this one. Now when you multiply, I highly recommend that you multiply conjugates first, because in doing that, you'll have no middle term. It just makes it a little easier. Now it doesn't matter. You could multiply the last 2 together, and that answer times this. Or you can multiply the first 2 together, and that answer times this. Either way. Let's go ahead and multiply our conjugates together using the FOIL method. The first times the first is x squared. Negative 2x and a positive 2x is 0. They drop out. The last times the last is a minus 4. That answer times x minus 3. Okay. Now I have 2 binomials, so I can just go ahead and use the FOIL method again. If you do have a trinomial, you would have to take the first term times everything and the second term times everything. It's a binomial, so I can use the FOIL. 2 binomials. The first times the first. Then this right here is a minus 3x squared and a minus 4x. Now you can't combine those, so I have to leave them separate. There's our O and our I. The last times the last is plus 12. Okay. So again, check that. You can put in a negative 2. When you do put it into an even power, you have to have parentheses. And you'll get 0. Put in a positive 2. Put in a 3 for your x's, and you'll come up with 0. All right. Well, I think we're done. So just those 2 ideas of the discriminant. Yep. With the discriminant, and also with coming up with equations giving the roots, which we've done before. You just kind of work backwards. All right, well, you guys have a great day. Let me know if you have any questions, and I'll go ahead and open up one more assignment. I think we'll have maybe 2 more sections, 3 at the most. I maybe just 2. Okay, all right, so keep up with the homework. All right, thank you.